My people, I hope you are doing great. Welcome. Finally, we've made it to chapter 7. This is exciting, isn't it? Probably not as exciting for me as it is for you. Okay, chapter 7, we start out with all kinds of stuff. So I apologize. I have no idea how long this is going to take, but we got 17 of these to get through. Let's cut right to the live action. Some new words for us. So as we enter into chapter 7, it's all about exponential stuff. Exponents. Probably your least favorite thing. Constant, I don't know that that's necessarily a new word for us, guys. Constant, just a number all by itself. 12, 22, 18, 44, 1 half. Okay, that's just a constant. A monomial, this is we can call it a constant, call it a variable, right? Either one of those things by itself we could say is a monomial. Or, here's the tricky one. I'll say the product means multiply of a constant, if I can write, and a variable. Good luck writing all that down, okay? So what does that look like, right? These are great definitions to have. What does this look like? So let me give you some examples of monomials. So constants here, I'll quickly put a few under here. So like 25, negative 10, 8.5, okay? Those are fine. 1 half, whatever. Monomials. Here are some examples of monomials. 8x, okay? That would be the product of a constant, 8, and a variable, x. Maybe we could have 2 variables in there. Aha! That would work too. Okay? Are we allowed to put exponents on these? Sure we are. So you could have like 1 half y cubed. Okay? What about things like, again, these could all be negatives and decimals and all that. What about like x plus y? Could we have something like that? What about 8 divided by x? Could we have something like that? No, right? Remember, we're only allowed to have the product or multiplication. So if we see addition, if we see division, not a monomial, okay? So there we go. Some new words for us. And one of the things we'll have to do is just identify, right, particular expressions, and is it a monomial, is it not? So determine whether each one of these expressions is a monomial. So I see subtraction here, absolutely not, no, you are not a monomial. 8f squared g, of course you are, right? That is the product of a variable and a constant. 3/4, that would be a constant. So we could say it's a monomial, okay? 5 divided by t, no. No, you are not. Which expression is a monomial? Okay? Division, boom, you can't be it. Subtraction, nope. Clearly got to be this one. Okay? Look, we're already on the 4th slide, people. Get excited. Okay, so that was the easy stuff. Now we get into the annoying stuff. The first couple lessons of chapter 7 are all about exponents, okay? And how do we deal with operations, typically multiplying and dividing, when we have exponents in them, right? We are trying to get ready for these things we call quadratics that have exponents in them all over the place, and we kind of need to know how to handle them. So that's why we're going to do all this stuff. So we're going to get into our product rule, okay? Our product rule merely says this. If we are multiplying and we have 2 variables, doesn't matter what they are, a, b, x, y, and we have the same variables, and they're raised to different powers, okay? G to the 4th times G to the 6th. Keep the base would be G, we probably need to talk about that real quick, and add the powers, okay? So here, I'm gonna write down here, B to the 4th power, okay? We all know that this is the exponent. That is not a new word for us, right? What is a new word is this little fella right here. Whatever your variable is, or number, okay, that's what we call the base, right? 4 is the exponent, the variable in this case, b. Probably not a good idea to use b. Watch this. You guys are all mad now because you have to erase and put a t there. Okay? T is the base. Could have had an x there. Okay? Keep the base, add the exponents. That's what product rule says. Again, we have about 4 main rules we are going to deal with. This is our first one. Okay? All right. Let's see it in action, because that's always probably what makes most sense to all of us. If we have numbers here, I want you to multiply them. Coefficients. Do I have a coefficient here? It's an invisible 1. We're going to multiply that invisible 1 with negative 12, and that's what my coefficient is going to be, negative 12. Then I'm going to take r to the 4th times r to the 7th. Again, keep the base, that would be r. Add the exponents, 11. There you go, negative 12 r to the 11th. Okay, keep the base, add the powers. You're going to hear me say that no less than, I'm going to go with 27 more times. Okay, you can keep track and let me know how I do. Again, multiply your coefficients. That is step number 1. 6 and 5, right? So those together give me 30. C's, keep the base, add the exponents. I know what you're thinking. I did that wrong. That's a 6. No, I didn't. Right? There are invisible 1s. Right? This C is really raised to the first power. This is probably a bear trap waiting to happen for us, okay? So keep the base C, add those powers. There you go. Keep the base D, add those powers, okay? So 30, C to the 6th, D to the 7th. Okay. I feel like we should talk about standard form, but we'll get to it eventually. All right, same thing here. Multiply coefficients. That would be 20. Keep the base, add the powers. Okay? This is, again, this rule will seem very simple, okay, until we add another rule here in just a little bit, and then it will become maybe not so simple because now there's a second rule. Okay? If you'd rather have this in parentheses because that makes more sense to you, that's fine. Okay? Multiply your two coefficients, negative 6. Again, if you need to write in that there's x to the first power, you need to write that 1 in there. I want you to do that until you get comfortable knowing that, okay, yep, keep the base x, add the powers. 1 plus 2 is 3. Keep the base y, add the powers. 2 plus 3 is 5. Okay? There we go. Negative 6, x cubed, y to the 5th. Guys, this is what we call standard form. At some point in time, we're going to have like a little formal definition of it, but standard form says, well, we've done this before. Variables, alphabetical order. If we have the, and we like to, keep them highest power to lowest power. If we have other things in there, that'll make more sense when we have other terms. Okay. All right, there we go. So that was the end of product rule. There's rule number 1 for us. Rule number 2, here it is right here. Let's read about it. Power of a power. Okay, we got the word power a lot in here. Interesting. So I look at these two examples, and we have something that's raised to a power, and then it's being raised a second time to another power. Okay? Hence the name power of a power, right? We call this power rule, or power to a power. So we have an exponent that's being raised to another exponent. Okay? Interesting. Okay? We could treat it like product rule, right? Because, guys, 3 to the 3rd power, right? It's just like repeated multiplication. It's just 3 times 3 times 3. So if we had 3 to the 3rd power, and then we were going to raise that to the 3rd power, or any other power, we could just do a whole bunch of multiplying, and then do our product rule, and keep the base and add all the power, right? There's got to be an easier way. And there is an easier way, guys. Keep the base, multiply the powers. Okay? Keep the base, which would be 2, multiply the powers. This is a power to a power to a power. You got to work your way from the innermost parentheses out each time, okay? So the first thing I'm going to do is right here, okay? So 2 to the 3rd being raised to the 3rd power. So keep the base 2, multiply your powers, that's 9, okay? That's what we get here. Then we see this bracket with a 2, okay? So now we have 2 to the 9th power, and we're going to raise that to the 2nd power. Again, keep the base, multiply the powers. That's it. Okay? I can show you the repeated multiplication way. No, I don't want to do that. Right? Just this is the rule. Use power to a power rule here. Okay? Simplify this one. Again, the first time we simplify, I'm just getting rid of 4 to the second power raised to the second power. So this is going to be 4 to the fourth power. Right? Then we have to raise that to the third power, or cube it. Keep the base, multiply the powers. 4 to the 12th. Good to go. Okay? Oh boy. All right. So that's just power rule in itself. This is going to look a lot like power rule 2. This is power of products. Okay? Power of products. Okay, so product means we're multiplying two things together already, right? As they have here, like negative 2xy cubed, and we're raising it to the 5th power. This is where power rule gets super complicated, folks. Super complicated. And we complicate it even more with a word problem. Let's go back here. Can we just get a straightforward? No, we can't get a straightforward one. All right. So I'm going to make up one here real quick. Go back to this slide, guys. Okay. So I would like to do 2x to the 4th y squared, and I would like to raise everything to the 3rd power. Okay. So here's what I want us to do. Right? We have to understand that, right, we're just multiplying all 3 of those terms together. 2x to the 4th, y to the 2nd power. We need to raise each one of them to the 3rd power. The most common mistake is to just raise the 2 variables because they have their exponents with it, and that's what we know, right? So I would expect if we were rushing through, we would say, oh yeah, this is 2, keep the base x, multiply, make that 12, keep y, make that 6, okay? That is not the right answer. It's 2/3 of the right answer because this is right, but we need to take this 2 and raise it to the 3rd power as well, right? Remember, that 2 has an invisible 1 with it, so we have to raise that 2 to the 3rd power. So 2, keep the base, 1 times 3, so this is, 2 cubed. Okay, now the great debate is, do I change this to the number 8 or do I leave it alone? I say if it's a number smaller than 1,000, change it to its number. Okay? So make this 8x to the 12th, y to the 6th. Okay? Like if you had, 72 to the 12th power, just leave it as 72 to the 12th power. Nobody wants to write out that crazy long number. Okay. All right, here we go. Everybody, I need you to draw your very best cube. So draw your very best cube right over here, okay? You draw yours. I'm going to draw mine right over here. I am a cube drawing expert. You don't even know how good my cube drawing skills are. Look at that. That is terrible. Whatever, you get it. Okay. Express the volume of a cube with side length 5xyz as a monomial. So I have to find the volume of a cube, and all they've told me is it has a side length, right, of 5xyz. Okay. Volume of a cube. Does anyone know how to find the volume of a cube? Well, then Google it. What are you waiting to listen to me for? Length times width times height. Okay? So we go length times width times height. Now, it's a cube, folks. It's like a 3-dimensional square. So what's special about a square? Well, we know all 4 side lengths are the same. Cube is the exact same thing because it's a 3-dimensional square. So that means all of my length, my width, and my height, they're all this 5x, y, z too, right? Yeah, z. Okay? Beautiful. All right, so here's what this looks like. So the volume is literally, guys, just going to equal 5x, y, z, right, to the third power. No, you can't multiply it by 3. Okay, that doesn't, no, because it's this times this times this. It's not this times 3, okay? We're multiplying this times itself times itself. If you would prefer to make this into a really big product rule problem, you could do that, right? You could also, I suppose, write it, guys, like this: 5xyz, 5xyz. Okay? Remember, repeated multiplication, that's what exponents are for. They make writing things simpler for us, okay? So I'm going to get rid of all this. Again, you can write it that way and you can solve it. I promise you, you will get the same answer. I like to work smarter, not harder. So I need to raise all 4 terms to the third power. Keep the base, multiply your powers. So this is 5 to the third, x to the third, y to the third, z to the third. Change that number to 125. Okay? So 5 to the third, just 5 times 5 times 5. We'll make this 125. There it is, expressed as a monomial, right? This is a monomial. Okay. This isn't terrible, folks. Till we get to this one. Express the surface area of a cube. Okay? So what is surface area? Well, we all know what area is, right? If I said, hey, find the area of this square, we would take length times width, and yep, we would understand that would give me the area here. Okay? Now again, it's a cube, so 2pq is our length, width, and height for every edge, every side length, whatever you want to call it, of our cube. So surface area. We need to find the area of one face, okay, and then multiply it by that many faces that we have. So how many faces? When I say faces, guys, I'm talking about like this is one face of the cube, and then here's another face, and then here's a third face. So how many other faces are there? So there's 6, obviously, okay? So I need to find the surface area of one side or one face. Let's just say the area, okay? And then I need to multiply that by 6, okay? Because there's 6, right, faces, sides of that cube. Okay, so the area is just going to be 2pq times 2pq. And we're going to multiply that whole thing by 6. Okay? Where did I get this from? From the picture. These are my side lengths. So we're going to go ahead and we can flip back now. Again, we could write this as power rule, 2pq, right? And then raised to the second power. Or we could just say, hey, you know what? I can handle this with product rule because it's really not that bad. This will turn into 4, p to the second power, q to the second power. Then I need to multiply this by 6. Because there's 6 faces. All right? All right, so when we do this, what do you guys think? Pause the video if you want. Give it a shot. Figure out what you need to do. Bum-ba-da-bum. Yes. If you wrote down 24, p to the second power, q to the second power, you're a winner. Ding, ding, ding. Congratulations. Okay? There we go. That wasn't so bad. Okay. Man, we are doing a lot today. Lucky you. All right, so now we're going to simplify some expressions. This is good. All fractions are in simplest form. I hate fractions. This escalated really quickly, didn't it? We had some nice problems, and then they just got to go and do this. Look at this. Where do we start? No, like seriously, where should we start here? I have no idea. I don't know. Of course we know. All right, guys. Here, let me zoom in on this a smidge here. All right, there we go. Much better. Okay, so look, we just need to work on our two parentheses. So it's really two problems, right? It's the first half right here, and then we have this second half over here, right? Here is the second half. Change colors for you. Here's the first half, all the way, including like here, okay? So I need to figure out what does this turn into, okay? Then I need to figure out what does this turn into, and then we're multiplying them together, right? Work from the innermost parentheses out. So this looks like a lot. We're just going to take it one step at a time. So I'm going to take a look. I'll do this part in red. I'll do this part in green. All right, so this is going to be 8, g to the third, h to the fourth, and we're going to raise that to the second power. So power to a power, right? Everybody keeps the same base. Multiply all of your powers by 2. So this should turn into 8 to the second power. And I'm going to leave this alone for now, okay? I'm not going to turn this into 64 yet, is what I'm saying. G to the 6th, h to the 8th, okay? And you can keep the brackets or you can turn them back into parentheses. I really don't care, okay? Now I need to raise all of these to the second power. So again, keep the base. Let's multiply by 2. So 8 to the 4th, G12, H16. Okie dokie. I mean, I suppose I could write that a different way, but it's just really mean to start off with 8. Okay, here we go. 2 is to the first, G is to the first, H is to the fifth. We're keeping all of those bases, 2, G, and H, and we're going to raise everybody to the fourth power. Okay? So this is going to be 2 to the fourth, G to the fourth, H to the 20th? Wowzers. Okay? All right, so let me write that down here by it. So 2, I guess we don't have to have this. We could just have the old multiplication dot. 2 to the fourth. Oh, that's going to be nice. G to the fourth, H to the 20th. You're going to learn about the unsuspecting rule that we rarely use. So now I'm glad I didn't change what I was going to change earlier. Okay. So G and H, right? We know what to do with these two folks, right? Absolutely we do. Okay. What are we going to do with these two things here? Right? Because in all of our other problems, we just said, hey, multiply the two coefficients together, right? We'd have like 2 and -8 or something. And we'd multiply and say, yep, -16. Okay? Well, here is a second power rule, right? And it is not a very common one. Okay? So this is our powers of products. Okay, so we have two products, and they have the same exponent in this time. Okay? We do actually do the opposite in this scenario. So we are going to keep the exponent, 4, and we're going to multiply their bases together. Okay? We will not see this rule very often. Okay? So I'm not going to be mad if you don't catch this. Here's what you could always do. You could take 8 to the 4th power, type it into your calculator, figure out what number that is. 2 to the 4th power, whatever that is, 16. Multiply that by 16, and you could give me that big number. It's going to be probably a pretty big number. Okay? Or if you're super duper awesome, like some people, you can say, hey, these are to the same power, 4. So this is just going to turn into 16 to the 4th power. Okay? Go ahead with your G's. Keep the base. Are we adding or multiplying these exponents? We're adding. This is just product rule here, folks. We got rid of all the power rule up here. So this is going to be G to the 16th, H to the 36th. That's awesome. Okay? 16 to the 4th. I have no idea what number that is. I'll tell you here in just a second. 16 to the 4th is 65,536. I prefer to write it like this because it's a little bit smaller, okay? So guys, we have two power rules, okay? This is our most common one that we see, right? Keep the base, multiply the powers. This is the other power rule, okay? When we have two bases that are different, but two exponents that are the same, we are allowed to multiply those bases together, okay? So there we go. That was a lot. I apologize for all that. And then here's this one. This one's the same thing, guys. Okay. If it helps you, I know a lot of you like to do the color coding thing. All right, make this one red. We'll make this one in blue. Okay, work on each half, and then we're multiplying those two together. So this is the same structure as we're going to have before. We're going to need to do power rule, and then product rule once we know what all of this turns into. Okay, order of operations. Okay, so 2 is also to the first, c to the second, d to the third. All of these are getting raised to the second power. So this is going to turn into 2 to the second, c to the fourth, d to the sixth. Then I have to raise that to the third power. Okay. Keep all your bases. 2 is now going to be to the sixth, c to the 12th, d to the 18th. Okay? Got it. Take care of this one here. Okay, again, 3 to the first, c to the fifth, d to the second. Until you understand that there's always a 1 here, just write those 1s in. Okay? All right, so 3 to the 1 times 3, c to the 5 times 3, and d to the 2 times 3. Okay, c to the 15th, d to the 6th. Okay. Darn. Guys, my fancy rule is not going to work here, is it? No. No, it's not, okay? Here's things that we could do. We could try to write both of these, right, as different bases with a different power but mean the same number. That's really not possible here because we're not going to, at least not off the top of my brain. Here it's a Saturday morning at like 9:30. My brain's not fully running on math power yet. Okay, but I don't think we can. Nor do I think either one of these are really big numbers. 3 to the third power is just 27. 2 to the sixth power is going to be somewhere maybe like 64, 32, something like that. Okay. Anyway, well, we should probably figure that out since those are my first two numbers. Handy dandy calculator. Too early, guys, to calculate. 2 to the sixth power is 64. Okay. All right. 3 to the third power, 27. Okay. I guess we could multiply those two together. I mean, it breaks my rule of 1,000, but what do you want me to do? 1,028. I'll make an exception because it's a Saturday morning. 700, right? And 28, yeah. Okay. Okay. C's, keep the base, add them up. So c to the 12 plus 15, I believe to be 27. D to the 18 plus 6, 24. Okay? And there you go. There's our answer. Good news. That's the end of this. Okay? So guys, chapter 7, don't you pause that video. Listen to this really quickly, okay? So guys, chapter 7, as I've mentioned, is when things start to get a little bit challenging for some of us. Some of you guys look at this and be like, I got this, okay? In our Schoology folder, you will find a PDF called Skills Practice, right? Which will literally just give you more of these. So if the book work isn't enough, right? And you're like, man, I need some more practice. Or, hey, I could try the homework. Ain't gonna go so well for me, okay? If you need more practice, you know your ability with this better than anybody else, or when we get into 7.2 and 7.3, okay? Find that Skills Practice PDF, okay? And try it. Like you might not need help on everything that we did today, but you might want to see more of these, okay? just blop down to those questions. Try them, check your work. Okay, if you're still stumped on it, ask me. Okay, so anyway, that should do it for the live action for today. Everything else is status quo, right? So we've got our bookwork. We now know about skills practice. We should have a quizzes in there too, so that you guys are awesome at our first couple of exponent rules. See you, people.